So we have 3, and always put it in brackets when you're putting it in. And go straight to the calculator then, and you won't have to go and add the fractions together or anything, or simplify it. So you'll get 9/10, and that's all we do for part A. Let's just sub it in. Right, part B, it says use calculus. Calculus, remember, is the same thing as differentiation or dy dx or f dash x or whatever you want to call it. So we know we're going to have to differentiate that function, and it's a local minimum. We'll come to that in a second. F dash x is equal to, we do the power times the number in front. So 2 times 5 is 10, and then it's just x, and then minus 20x, so really just a little 1 there, so 1 multiplied by minus 20 is minus 20, and the power drops down, and then the 2 is completely gone. That's the differential. Now we want to find a local minimum, so what we do to do this is that we're going to let it be equal to 0. That's something you have to remember. So 10x minus 20, we just let our answer there be equal to 0, and then we go on and solve. So I'm going to bring the minus 20 across the equal sign. 10x is equal to positive 20. And then to get x by 12, I divide by 10. 20/10, x is equal to 2. So we've to find the coordinates of, we've to find both coordinates. So what's really going on here is there's a quadratic somewhere on the graph. We don't know where, but at a local minimum, the dy dx, or the differential, has to be 0, because that's the slope of the tangent, and the tangent has to be 0 there. So what we found is that the x coordinate is 2. So if you imagine it on the graph, there's 2, there's 1, there would be 3, 4. We found that the x coordinate is 2, but we need to find out what the y coordinate is. So we take this graph, the actual original function, and we're going to sub in a 2 in for x everywhere. So I'm getting f of 2. That's 5 times 2 squared minus 20 times 2 plus 2. Then that would be 20 minus 40 plus 2, that would be minus 38, I think. Sorry, minus 18. Therefore, our point is 2 minus 18. And that's all we do there. Right, next part. We have to find the rate of change, so of g of x, that is g dash x. So that's g of x. So really all our g dash x is going to be is our slope. So you imagine any line, that's a linear, that's a line. So if you imagine the line y is equal to 2x plus 5, if you were to differentiate that, or so we'll call that, so we'll just call that g, just pretend that was g of x for a second. So if that was g of x, well then g dash x would have to be, if I differentiate it, it would just be, that would go to a 2, and then the 5 is gone. So that really, remember, then 2 is the slope, because if in y equals mx plus c, that's the slope. So what I'm getting at is that it's just the slope really. So the slope is what we're looking for here. And remember, slope is the same thing as rise over run. So if I was to pick 2 points on that graph, one is there at 0, 1, and one is there. If I was to get the rise and the run from those, so the rise is 2 up and the run is 3, and the graph is going up from left to right, so therefore our rise over run is 2 over 3. And that's all it is there. It's just reading that the slope It's reading the slope off the graph, so it's recognizing that anytime we differentiate, really we're getting what the slope is. That's all for that question.